Okay, so this is evaluating a function from a graph. So we don't really know what the f function is here, except we have a picture of the graph. We don't really know the function. It looks to be a piecewise function of some sort. So we would just want to evaluate the function when x is equal to, remember, we do f of x. We're always inputting the input of x, and what's the corresponding y value? What's the f of x value? Right, so when x equals 2, so x equals 2 anywhere on this kind of vertical line, that's when x equals 2, and it crosses the function, it looks like at the point 2, comma 1. So the answer to f of 2, what is f of 2? It's 1. Right, when the input is 2, this particular function has an output of 1. That's the y value, the f of x value. F of 2 is equal to 1. F of negative 4. So now I'm looking, where does this function, where does the x value equal to negative 4? Of course, here's negative 4 in the graph. If you draw kind of a vertical line up, it crosses the graph at negative 4, comma 2. So f of negative 4 is equal to 2. Just getting the information from a graph here. So f of 5, we're saying the x value is 5. When the x value is 5, looks like that's this point right here. That's 5, comma 0. So the corresponding y value, or f of x value, is 0. This is asking the question in reverse. So it's the same graph, but it's really asking it kind of a different way here. So this one, it's saying we don't know x, but we know the y value is negative 3. Well, where is y equal to negative 3? That's everywhere on this dotted horizontal line, I should say. And it looks like it crosses the function only in one spot at 4, comma negative 3. So that's when the y value is negative 3. The fx value, so x equals 4 would be the answer here. We're given a y value of negative 3. We're trying to find the corresponding x value. So just to make sure you're getting it, what is f of x? What is x, essentially, when y is equal to 1? So for this function, it looks like, when y equals 1, it's kind of a horizontal line there. It crosses right there at about 5.2, I don't know. It crosses right there when x is 2, and crosses right there when x is negative 6. So there'd be 3 different solutions. X equals negative 6, x equals 2, and x equals, I don't know, somewhere about 5.2 or something. Find the domain from a graph. We could do this algebraically. We've done this before, where we say whatever's underneath there has to be non-negative. It must be greater than or equal to 0. We've factored this and done the squiggly line, if you remember how to do that. Squiggly line, you'd have 2 points, negative 2 and 2. The graph would, let's see, if I plug in a value bigger than 2, 3 minus 2 is positive, 3 plus 2 is positive, 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 positive. They're both odd. So the graph looks something like this, roughly. Closed circle at there and there. And so during what intervals is this graph? There's 3 intervals here. There's kind of the interval smaller than negative 2, the interval between negative 2 and 2, and the interval 2 or bigger. And so the 2 intervals that are greater or equal to 0, the y values are greater or equal to 0 would be from negative infinity to negative 2, bracket. That's a bracket, hard bracket there. Union with 2 to infinity right there, and that's a bracket right there. Okay, but let's just get it from the graph. So let's graph this thing and see if we can do it from the graph. So we're going to graph x squared, square root of x squared minus 4. So go to graph page, square root of x squared minus 4. And it looks kind of like that. If you want to do a trace, which might be nice, menu 5.1. I'm especially concerned about, like, I know there's no values right there, but if I scroll over to 2, press enter, that is on the graph. Maybe scroll to negative 2, press enter. That is on the graph. So it looks like it has definite starting points there. on the graph. So see if this matches what we have. Where is this graph? Where's the domain? Where there looks to be no domain, like, between 2 and -2, there's really no points right there. The graph kind of goes up and to the right forever, up and to the left forever. Seems to start at 2 and go higher, start at -2 and go lower than that, which exactly matches this. So the only thing that's different is this is kind of erased, or it's not there on this graph because it's not even negative. It's just not even a real answer there. So our domain is these two things. If you look at that, by the way, the range, the y values, looks to be like y is greater than or equal to 0. That the lowest this graph goes is 0 for the y values. It doesn't go any lower than that. So oftentimes range we just get from the graph. It's usually the easiest thing to do there. What's the domain of this graph? And let's just assume that's a closed circle right there. It's hard to tell, but that one's definitely open over there. Just change that color. Okay. So what is the domain? The domain looks to be the furthest leftmost point seems to be this point at -5, -1. The furthest rightmost point is at 4, 5, but the 4 doesn't seem to be included there. It's an open circle, which means it's not really included. So the domain would be at the leftmost, the smallest bound would be -5. That's a bracket, a hard bracket. The upper bound would be 4, and that's a parentheses. It does not include 4 there. Range, or how low it goes, it seems to be like -1 is the lowest. How high does it go? It does go up to this point here, so -3, 6. So it looks like that's the max. So I'd say -1, 6, bracket at 6, and bracket at -1. So this is the formal definition. Don't let it intimidate you, but this is the formal definition of increasing and decreasing functions. So this is an increasing function. Now remember, when you see this, think of it as a y value. When you see this, think of it as a y value. F of x is our new name for y. So we're saying when the y value of the function, wherever the x value is x1, is smaller than the y value when the function's evaluated at x2, then that is a increasing function. So your graph might look something roughly like this. It doesn't mean it just kind of goes up smoothly. Who knows what it does between those 2 points? But if you look at the distance of how tall each of those graphs are there, like this distance is this, right? That's the y value at x1. And if I do this distance, so right here, that's the y value, or f of x value, at x2. And so as long as the red line, the red height there, I guess, the y value of that, is smaller than the blue height there of the y value, then that is an increasing function. Practically speaking, I mean, you can just kind of tell that the function is kind of going up, right? It's going up in that interval from x1 to x2. It only goes up. It doesn't actually go down there. So it's increasing from on that. Function's decreasing. Again, if you so this is a y value, this is a y value. So if you had, say, a point up here and a point down here, and the function kind of went down like that. So it's saying that this y value is this red line, and this is blue line, and we're saying the y value for the x1 is larger than the y value for x2 there, so it's taller. So it's kind of going down. And the graph looks like it's going down. It's kind of intuitive. Don't let the definition, the formal definition, kind of scare you off here. Is an easy concept. Just what interval is the graph increasing and what interval is the graph decreasing. Let's just look at a couple examples. And we're going to look at that from the graph mostly here. So let's go ahead and graph this one. So let's get our graph, our calculator out, and we're going to hit the home key, go to a graph, and x to the fourth. Oops. X to the fourth plus 4x to the third plus 4x squared plus 2. And that's an okay window, but you know, I'd like to get that a little bit bigger here. So that's one. Just try to adjust this a little bit. I'll make that one also. Okay, that's a pretty good window. Okay, so we can see different parts of this graph here. I'll try to see it so you can see. So let's take a picture of that. Let's kind of drag it over here. Well, let's before we do that, let's use our command on our calculator. So hit the menu key, trace 1, and you really want to find these points. The minimum point, I'm going to press enter when it says minimum. When it says maximum, press enter. And this one says y-intercept, but it's also the minimum. I'm going to press enter. The calculator thinks the y-intercept is more important, so it tells you about that point. So now that I have those points labeled, you really want to use trace to find those nice points. So it says where are the local maximums and minimums. These are not necessarily like the absolute max for this graph would be infinity, right? I mean, it goes up. This graph goes up forever, essentially. You know, it goes up forever and to the right and to the left there. So these are relative maximums and minimums. So we do that first, and then the second step is really to find the intervals where it's increasing or decreasing. So you can probably see this pretty easily, but it looks like this first interval is a decreasing interval. Same thing from here to here is a decreasing interval. So let's talk about the decreasing intervals first. So for those decreasing intervals, you have to name it by its x values. So that's very important that we're talking about x values. You do never name an interval by its y values. So I'd use interval notation. So that first one, it looks to be the interval from negative infinity. So this is decreasing. The decreasing intervals are negative infinity, comma, -2. Again, I'm using x value, not y value there. And by the way, when you're doing increasing, decreasing, it doesn't really matter if you use brackets or parentheses. I know that's weird. It's different than domain and range. We're very specific about that. There's actually a math argument. You can go to forums and see, is a function, when it reaches its lowest point, is it still decreasing? Is it not increasing? The College Board accepts either answer, so I'm just going to put a parentheses there rather than a bracket, but not for domain and range. We're very picky about that, but for intervals of increasing, decreasing, we're very loose about whether it's a parentheses or a bracket there, so I'm not going to worry about it. Another decreasing interval would be from -1, again, I'm using x values, notice I'm using x values, to 0. And again, it doesn't matter if it's parentheses or brackets really there. So those are the two decreasing intervals. And then there are a couple of increasing intervals. It's like this one and this one. And so we're going to kind of name those. So increasing intervals, we always name them by their intervals, always with x values. Don't forget x values. So we're looking at -2 to -1. So -2, comma -1. And then also from 0 to infinity. So from 0 to infinity. And those are your two increasing intervals. So this is kind of like a W. It goes down, goes up, goes down, goes up. And we're naming those intervals by the x values, not the y values. It doesn't go from 3 to 2 there. It goes from -1 to 0 as far as the x values are concerned when it goes down. So you try this one on your own, go ahead and graph it in your calculator. I'm going to go ahead and skip that step. Well, let's do it, sure. So if you hit the home key, go to graph, 12x squared plus 4x to the third minus 3x to the fifth. Wow, pretty intense graph. Kind of see it goes up and down. I'm not sure what it does. So let's go menu, window zoom, zoom out for a minute. So just gonna kind of click there. Okay, I can see the whole graph, but the x values, it's way too skinny now. So I'm just gonna adjust this to maybe -5, maybe +5. I'm not sure what to put there. That's not too bad, right? So move that out of the way. I'm just changing that to 1. It just makes it. Oh, I see. Maybe it's not so good to be 1 there. Let's go to menu, window zoom, zoom settings. So let's make that 10, I guess. Oh, that's too much. Menu, window zoom, window settings. Let's make the X scale 2 and the Y scale 5. It's not terrible. Okay. So I'm going to use the menu key. So menu, you didn't really have to do all that. So maximum, I see 1 there. Press enter to lay down the point. That's a 0 and also a minimum. So I'm going to press 0 and lay down the point. So I've really got both points there. You can bring that over. So this is what we have to work with. So this is going to be, let's see, it looks like it goes down at first. So this part of the graph, it's kind of going down. So that's be a decreasing interval. And that looks to be from -infinity to an x value of 0. I'm notating the x value there. Then it seems to increase right from here to here. That's an x value of 0. So this is increasing. X value of 0 all the way to an x value of 1.4. And then it goes back down, so it decreases. Again, look at the x value of 1.4 all the way to infinity, where the x value is increasing there. So that's a decreasing interval there. And you've got it. That's the lesson.